Okay, so here it has been told that on adding which of the following, the pH of 20 ml of 0.1 normal HCl will not alter. Okay. So now the pH of 20 ml of 0.1 normal HCl, pH of 0.1 normal HCl is minus log of concentration of H plus. Now concentration of H plus will be equal to 0.1 molar only, since 1 H plus ion, 1 mole of H plus HCl will give 1 mole of H plus ion only. That will be minus log of 10 power minus 1, that is equal to 1. Now, now 500 ml of HCl of pH equal to, it's 500 ml of HCl of pH equal to 1. Now if you have 1 ml of 1 normal HCl, in the first case here the concentration is 1. So therefore H plus ion concentration, that will be the number of moles of H plus, which is 0.02 ml, since so it is 0.02 liter. 20 ml means 0.02 liter. 0.02 into 0.1 plus 1 ml means 0.001 into 1 divided by so 20 plus 1, so 21 ml, so 0.021 liters. So this much will be the concentration of H plus. That will be 0.002 plus 0.001, so it will be 0.003 divided by 0.021. So this will be 3 by 21, so 1 by 7 molar. So therefore the pH will be equal to minus log of H plus concentration, which is 1 by 7, so it is log 7. So which is not equal to 1. Now in the part B, since while log 7 is slightly less than 1, will be less than 1, since log 10 is equal to 1. Now in the part B, we add 20 ml of distilled water. So here the H plus ion concentration will be the number of moles of H plus, which is 0.02 into 0.1 divided by the net volume will change, which is 40 ml. So that will be 0.04. So that will be also 0. So this will be 2 by 4 into 0.1. So it is half, 0.05 molar. So therefore pH will be equal to minus log of 5 into 10 power minus 2. So this will be 2 minus log 5. So log 5 is 0.7. So 2 minus 0.7. So 1.3, which is not equal to 1. And in the part C, we have to add 1 ml of 0.1 normal NaOH. So here the number of moles of H plus ion, that will be, or the H plus ion concentration, that will be equal to the number of moles of H plus which is obtained from HCl is 0.02 into 0.1 minus, here since NaOH is there, so it will slightly neutralize this HCl. So 1 ml of 0.1 normal NaOH, so that will be 0.001. Since 1 ml means 0.001 liter, that into 0.1 divided by so 21 ml, so 0.021 liter. So this much molar it will come. This will be 0.1 into 0. 020 minus 0.01, that is 0.019, divided by 0.021, that is 19 by 21 into 0.1 molar. So therefore pH equal to minus of log of H plus ion concentration, that is 19 by 21 into 10 power minus 1. So which is actually 1 plus I can write log 21 by 19. So which is slightly more than 1. So it is not equal to 1. And in the part D, pH is equal to 1. So here pH value, so the initial pH was 1 only. So here 500 ml is added, 500 ml of pH 1 means 0.1 molar HCl has been added with 20 ml of 0.1 molar HCl. Now therefore the H plus ion concentration, that will be equal to the number of moles of H plus, that is 0.5 into 0.1 plus 0.02 into 0.1 divided by 520 ml, so 0.52 liters. So this will be equal to 0.52 into 0.1 divided by 0.52, so that this will be 0.1 only. So therefore here in this case pH will be equal to 1, means since it is minus log of H plus, that will be equal to minus log of 0.1 10 power minus 1, that is equal to 1. So here in the option D only, the pH will remain unchanged. So option D is the correct answer. Then here it is told an example of a neutral buffer is. So the first case we have ammonium hydroxide, which is NH4OH, and ammonium chloride, which is NH4Cl. And in the option B we have acetic acid, which is CH3COH, and sodium acetate, so CH3COO Na. In the option C, we have acetic acid, CH3COH, with ammonium hydroxide, so NH4OH. And here in the D, we have citric acid, citric acid plus sodium citrate. Citric acid so so citric acid, actually it will have some alkyl group, let's call it RCOH, and plus sodium citrate, it will be like RCONA. So here in the first case we have weak base plus the acidic salt of the acidic salt of the weak base. So here it is a weak base plus the acidic salt of the weak base. So it is a basic buffer, the basic buffer. And here we have a weak acid and its basic salt. So it is an acidic buffer. And here also we have in the option D also we have a weak acid plus the basic salt of the weak acid. So it is also an acidic buffer. Acidic buffer. And here we have a weak acid and a weak base. So it is a neutral buffer. It is neutral buffer only since these two will react to give CH3CONH4, which is ammonium acetate, which is a neutral salt with H2O. So option C is the correct answer. Then here it is told the conjugate base of H2PO4 minus is the conjugate base of H2PO4 minus. So the conjugate base will be obtained if we remove one H plus ion from H2PO4 minus. If we remove one H plus ion, then it will form HPO4 2 minus. So this is the required conjugate base of H2PO4 minus. So option B is the correct answer. Then it is told identify a species which is not a Bronsted acid but a Lewis acid. So Lewis acid it means that which can accept a lone pair of electrons. So which is electron deficient. That compound which is electron deficient, it means which can accept a lone pair of electrons. Accept a lone pair of electron. And Bronsted acid means which can give H plus ion. Bronsted acid means which is a proton donor. It's a proton donor means it can give H plus ion. So here, uh, for example, in the first option, we have BF3. So BF3 here octet is not fulfilled for boron. For boron, the octet is not completed. So it is an electron deficient molecule. So it can accept one lone pair of electrons. So it is obviously a Lewis acid. And since it can't give H plus ion, so it is not a Bronsted acid. It is not Bronsted acid. And in H3O plus also it can give H plus ion, so it is a Bronsted acid. And NH3 also it can give H plus ion, so it means it is also a Bronsted acid. HCl also can give H plus ion, so it is also a Bronsted acid. So here it is asked which is not a Bronsted acid, but it is a Lewis acid. So BF3 is the one which is a Lewis acid and not a Bronsted acid. So option A is the correct answer. Then here it is told the yield of the products in the reaction would be higher at. So here A2 plus 2B gives P plus Q kilojoule of heat. So here it is an exothermic reaction. So it is an exothermic reaction. So it means that if the temperature increases, then the value of Kc, which is the equilibrium constant, that will decrease. So Qc will be more than Kc, means the reaction quotient will be more than the equilibrium constant. So there will be a backward shift in the equilibrium. There will be a backward shift in the reaction. So it means that the temperature should be lowered. The temperature should be low, since then the equilibrium constant Kc will increase and then Qc will be less than Kc, then there will be a forward shift in the equilibrium. There will be a forward shift in the reaction. Um, so it means then only the yield of the products will be higher. The yield of the products will be higher. And then, so it should be at low temperature is favorable for the for the yield of the products to be higher. And here the pressure now here uh, now we know that Kp equals to Kc into RT power delta Ng. So now here delta Ng, which is the number of moles of gaseous products minus the number of moles of gaseous reactants. So that will be 1 minus 3, that is equal to minus 2. So it means that so so since the number of moles decreases, so the equilibrium will shift in that direction in which the number of moles decreases. So it means the pressure also has to decrease. So it means that the yield of the products will be higher when there is low temperature and low uh, where there is so okay. So equilibrium will shift in that direction in which pressure decreases. So it means since the number of moles decreases in the forward direction, so it means that if the pressure is higher, then only there will be a forward shift. Okay, so it means that low temperature and high pressure is required for the yield of the products to be higher. Now, 1 mole of ammonia was completely absorbed in 1 liter solution, each of 1 molar HCl and 1 molar CS3COH and 1 molar H2S4 at 298 Kelvin. The decreasing order for the pH of the resulting solutions is 1 mole of ammonia was completely absorbed in 1 liter of solution. Now NH3 is a weak base. Is a weak base. So weak base plus so 1 mole of ammonia is used in 1 liter of solution of 1 molar HCl, 1 molar CCCOH, and 1 molar H2S4. So here um, now the concentration of H plus in H2S4 is the highest, since here the concentration of H plus will be 2 molar, since why the here the normality of H2SO4 will be 2 normal only, since 1 mole of H2SO4 can give 2 moles of H plus N. So therefore, so the so the concentration of H plus will be the highest in H2SO4, and then 1 molar HCl, and then in CCOH. So it means the pH should have the reverse order, since if the when H plus concentration is high, then the pH value is low. So the pH will be the least. So the pH will be the least for H2SO4, and then higher for HCl, and then higher with CaCCOH. So it means CaCCOH is 2, HCl is 1, H2SO4 is 3. So will be 2 more than 1 more than 3. So it means option C is the correct answer. Now here it is told for the equilibrium so for the equilibrium CaCO3 gives CaO plus CO2. Kp equals to 1.64 atmosphere at 1000 Kelvin and 50 gram of CaCO3 in a 10-liter closed vessel is heated to 1000 Kelvin. Then the percentage of CaCO3 that remains unreacted at equilibrium is So now here, if you write Kp, CO2 is gas, calcium oxide is solid, and CaCO3 is also solid. So Kp will be equal to the partial pressure of CO2. And Kc also will be the concentration of CO2. Now Kp is 1.64 atmosphere. So 1.64 atmosphere is the pressure of CO2 at e- equilibrium in 1000 Kelvin. And now concentration of CO2 that will be equal to the number of moles of CO2, that is 50 gram divided by the number of moles of CO2, 50 gram by calcium is 40, carbon is 12, that is 48. So 48 plus 12, that is 60. 60 plus 40, that is 100. So 50 by 100, this much moles divided by 10 liter. So that will be equal to 50 by 100. So 1, 2. So 1 by 20 molar. 1 by 20 molar means it is 0.05 molar. Then the percentage of so now if we assume that CO2 is an ideal gas, then from here we can find out the pressure of CO2 by using PV equals to nRT. So P equals to N by V into RT. So N by V is the molar concentration. So therefore, the pressure of CO2 that will be equal to 0.05 into R, that is 0.0821 liter atmosphere per um, liter atmosphere per mole per Kelvin. So here into the temperature, which is 1000 Kelvin. So this will be equal to 82 into 0.05 means 1 by 20. 2 tens are 241, so it is 0, so it is 4.1, 4.1 atmosphere. So now the pressure of CO2 is 4.1 atmosphere. So here 50 gram. So it means here mm, 50 gram means half mole of CaCO3. This part is wrong actually. Here actually what is happening? So initially half mole of 0.5 mole of CaCO3 was taken, and from there X mole has reacted, suppose. Then X mole of COO and calcium and X mole of CO2 has been formed. Now the volume is 10 liters. So then, uh, therefore, the number of moles, uh, the percentage of CO3 that is unreacted, percentage of CO3 that remains unreacted at equilibrium. So that will be equal to 0.5 minus X by 0.5 into 100. So that we have to find out. So it means we have to find out X, means how many moles of CO2 has been formed. Now from the pressure of CO2, now therefore the concentration of CO2 we can find out. Um, from the pressure of CO2 also we can say the pressure of CO2 that is equal to so PV equal to nRT, means X into RT. X is the number of moles of CO2 that has been formed, and V is the volume, which is 10 liters. Therefore, 1.64 into 10, that is equal to X into R. R is 0.0821 liter atmosphere per mole per Kelvin, and T is 1000 Kelvin. So from here we can find out the X. Therefore, X that will be equal to 1, so that is 16.4 divided by 0.082 into 1000, that is equal to 82. So this will be 82 into 2, 2 to the 4, 2 to 16, so this is 0.2. So X equal to 0.2 moles. So 0.2 moles of CO2 has been formed. So now therefore the percentage of CaCO3 that remains unreacted, in the vessel, so that will be equal to, okay, 0.5 minus 0.2 divided by 0.5 into 100%. So that is 0.3. So 3 by 5 into 100%, that is equal to 5 to the 10, so 60%. It means 60% of CaCO3 remains unreacted. So option C is the correct answer. Then here it is told the pair of compounds which cannot exist together in solution is Na2CO3, NaOH, okay, NaHCO3 and NaOH. HCO3 and okay. NaHCO3 can and H2O can exist together, and Na2CO3 can exist with NaOH, but NaHCO3 is a basic salt. NaHCO3 is a basic salt and it can give H plus ion also. So it can't remain with NaOH since can't exist together, since it will react with NaOH to form Na2CO3, Na2CO3 plus H2O. So they will react. Since why NaCO3 is an acidic salt. It can react with NaOH, which is a strong base. So it can give Na2CO3 plus H2O. So they can't exist together in the solution. So option C is the correct answer. Then it is told in In presence of HCl, H2S results in the precipitation of group 2 elements but not group 4 elements during qualitative analysis. It is due to, in the presence of HCl is present, uh, then H2S will result in the precipitation of group 2 elements but not group 4 elements. In the presence of HCl, H2S results in the precipitation so group 2 elements means the alkaline earth metals. Alkaline earth metals which are um, beryllium, magnesium, calcium, strontium, and barium. And then group 4 elements, they are the D block elements, which are so now what happens when there is a dissociation, when there is dissociation of H2S, so then it will form 2H plus ion and one S2 minus ion, which is the sulfide ion. And HCl will also undergo a dissociation in the form of H plus ion and Cl minus ion. Since HCl also will give more amount of H plus ion, more amount of H plus ion. So due to common ion effect, the dissociation of H2S will be suppressed. It means the degree of dissociation of H2S, which is alpha, alpha will be decreased due to common ion effect. Decreased due to common ion effect. So it means the amount of uh, is the amount of sulfide ion which will be formed, that will be also decreased. Group 4 elements, group 4 elements, it means that uh, group 4 elements, it means that it is the carbon, silicon, and all that. So since sulfide ion formed will be less, so it will result in the precipitation of group 2 elements and not in the precipitation of group 4 elements. So the answer will be that it is due to the lower concentration, lower concentration of sulfide ion. So option D is the correct answer. And here it is told in the reaction, in the reaction FeOH whole thrice, the ferric hydroxide solid that gives the ferric ion Fe3 plus ion the aqueous solution plus 3 hydroxide ion in the aqueous solution. If the concentration of hydroxide ions is decreased by 1 by 4 times, then the equilibrium concentration of Fe3 plus will increase by if the concentration of hydroxide ion decreased by 1 by 4 times, then the equilibrium concentration of Fe3 plus ions will increase by. Okay. Now here you can write the value of Kc. So Kc will be equal to the concentration of Fe3 plus ions into the concentration of hydroxide ions whole cube, since solid should not be used. Now here if the initial number of moles of a ferric hydroxide is 1, then if x moles has reacted, then x moles of Fe3 plus and 3x moles of hydroxide ion will be formed. So the value of Kc, or the equilibrium constant of this reaction, that will remain unchanged. We know that equilibrium constant will remain unchanged even if the concentration of the products or the reactants changes. Even if the concentration of the products and the reactants changes, then also the equilibrium constant will remain unchanged. So that will be x into 3x whole cube. So that will be 27x power 4. That is Kc. Now, the new value of Kc, that is Kc dash, that should be equal to the concentration of hydroxide ion is decreased by 1 by 4 times. So x minus x by 4. So now it is 3x by 4. So it is decreased by 1 by 4 times. So minus 3x by 4. So it is 3 are 12. So 9x by 4. Then the concentration of, so it is decreased by 1 by 4 times. The equilibrium concentration of Fe3 plus will increase by, is decreased by 1 by 4 times. So minus 3x by 4. So the new value of Fe3, the new concentration of Fe3 plus 1, Fe3 plus ion, let it be y. Therefore, I can say it is y into 9x by 4 whole cube. So that will be equal to y into 9 nines 81, 3 nines 27, 729 divided by 4 4 16, 16 4 64 into x cube. So that should be equal to 27 x power 4. So x power 4 will cancel. Then, so this will be 27, 9 81s are 9 3s are 27, then 3 2s are 6, 2 3 7s are 21. So y will be equal to 64x by 27. It will increase by how many times? So that is y minus x. So that is 64x by 27 minus 64 minus 27x. So that will be equal to 7 357. Okay. Thirty-seven x by 27. Okay. So here I think that here the question is slightly wrong. It should be if the concentration of hydroxide ion is decreased to 1 by 4 times. So this will be, it means the new value of hydroxide ion, this part is wrong. It means the new value of hydroxide ion is 3x by 4. So therefore, the new value of Kc also will be equal to the old value of Kc only, since e equilibrium constant can't change. Now the new value will be y into 3x by 4 whole cube. That will be equal to Kc, that is 27x power 4. So y will be equal to 4 cube into 27x power 4 divided by 27x power 3. So this will cancel out, 27 will cancel out. So this is 64x. So here it also should have been asked that then the equilibrium constant, the equilibrium concentration of Fe3 plus will increase to, not increase by, it should be increased to. So it will increase to 64 times. Here as you can see that the new value of the the concentration of Fe3 plus, that is increased to 64 times, since y is equal to 64x. So option C is the correct answer. Then here it is told equilibrium constants K1 and K2 for the following equilibria are related as. So here in the first one, the equilibrium constant K1, that will be equal to NO2, concentration of NO2 divided by the concentration of O2 raised to half into concentration of NO. Now, and K2, that is equal to concentration of NO whole square into concentration of O2 divided by concentration of NO2 whole square. So which is nothing but 1 by K1 and its whole square. 1 by K1 whole square. It means that K2 equals to 1 by K1 square. 1 by K1 square. So option D is the correct answer. Then here it is told the reaction quotient QC is useful in predicting the direction of the reaction. Which of the following is incorrect? So if QC is more than KC, it means that the reaction will shift. The reaction, there is a backward shift in the equilibrium. Or I can say the backward reaction or the reverse reaction is favored. Or I can say the reverse reaction is favored. And then the part B, it is told if QC is less than KC, the forward reaction is favored. Now, if QC is less than KC, QC is less than KC, it means that the concentration of the products is lesser. So it means the forward reaction is favored. Forward reaction is favored, and in the part C, it is told if QC is more than KC, then forward reaction is favored. So option C is wrong. And D is if QC is equal to KC, it means that the reaction is in equilibrium. Means the reaction is in equilibrium. The reaction is in equilibrium since QC is equals to KC. So no reaction will happen. No reaction will take place. That means that option C is the incorrect statement. Option C is the correct answer. And here it is told the equilibrium constant of this reaction is 4 into 10 power minus 4 at 2000 Kelvin. Now in presence of a catalyst, the equilibrium is attained 10 times faster. Therefore, the equilibrium constant in the presence of catalyst at 2000 Kelvin is. So now the equilibrium constant Kc is independent. That means the value of the equilibrium constant Kc, it is independent of the presence of catalyst. The presence of catalyst, only only the equilibrium will be attained faster. Only the equilibrium will be attained faster since um, since the rate of the reaction will be increased due to the presence of the catalyst. So therefore the equilibrium constant Kc, and since the temperature is not changed, now the value of Kc, it depends on temperature only. It depends on temperature. So since the since the temperature is remaining unchanged, so the Kc value also will remain unchanged. So it means that option C is the correct answer. Now here it is told the relationship in between Kp and Kc is Kp equals to Kc RT power delta Ng. So then what would be the value of delta N for the reaction? Now delta N means the number of moles of gaseous products, the number of moles of gaseous products minus the number of moles of gaseous re reactants minus the number of moles of gaseous reactants in a balanced chemical equation. In a balanced chemical equation. So therefore when NH4Cl, it goes to NH3 gas plus HCl gas, then what happens? Then NH3 so then mm, so 1 mole of NH3, 1 mole of HCl is formed from 1 mole of NH4Cl. So therefore we can say that delta N, that will be equal to 2 minus 1, which is equal to 1. Okay, no, here, so it is the so gaseous products is 2 and the number of gaseous reactants is 0. So therefore it will be 2 minus 0 is equal to 2. So option D is the correct answer. Now here it is told that acidity of BF3 can be explained on which of the following concepts? Arrhenius concept, it can't be used. Bronsted-Lowry concept can't be used. Lewis concept can be used. Bronsted-Lowry as well as Lewis concept can't be used. Okay. Since why BF3 actually it is a Lewis acid. It is a Lewis acid only, and it is not a Bronsted acid. It is not a Bronsted acid, and it is also not a not an Arrhenius acid. It is not an Arrhenius acid. Since why it can't give H plus ion, it can't give H plus ion, so it is neither a Bronsted acid and it is not an Arrhenius acid. Since BF3 can accept one lone pair of electrons, it can accept one lone pair of electrons, so it is a Lewis acid. So it means the acidity of BF3 can only be explained by using the Lewis concept. So option C is the correct answer. Then here it is told the solubility of AgCl is least in. Solubility of AgCl. Now the rule is that the solubility of any salt, the, the solubility of any salt is inversely proportional to the concentration of the common ion. The concentration of the common ion. When there is common ion effect, the solubility will decrease. Means the solubility will be suppressed. Now here with AgCl, so AgCl is there, and in the first option we have NaCl. Now 0.1 molar NaCl that will give 0. So from here also you can see that the concentration of Cl minus ion that will be equal to 0.1 molar only, which is obtained from NaCl. And from BaCl2, from 0.1 molar BaCl2, the concentration of Cl minus ion that is obtained that will be equal to 0.2 molar, and 0.1 molar AlCl3. From there, the concentration of Cl minus that will be obtained, that is 0.3 molar. Since why 1 mole of AlCl3 will give 3 moles of Cl minus ion. So since the concentration of Cl minus ion is maximum in case of AlCl3, so here only in AlCl3 only, so the solubility of AgCl, so the solubility of AgCl in AlCl3 only will be the least. Be the least. So option D is the correct answer. And in pure water also there is no chloride ions. So the solubility of AgCl will be highest in pure water. In pure water there is no common ion effect. So it means the solubility of AgCl will be maximum in pure water. Then it is told the conjugate base of NH3 is. The conjugate base, it means that it should remove, so we should remove one H plus ion, so then it will form NH2 minus NH2 minus ion. So option C is the correct answer. So it is the conjugate base of NH3. And NH4 plus is called, here we are adding H plus. With NH3, if we add H plus, then we will have NH4 plus. So NH4 plus will be called as the conjugate acid of NH3. Then which of the following is the strongest base? Now, so which can give lone pair of electrons, or so the rule is that the conjugate base, the conjugate base of a weak acid, the conjugate base of a weak acid is a strong conjugate base, is a strong base. Similarly, the conjugate acid of a weak base is a strong acid. So Cl minus is the conjugate base of Cl minus is the conjugate base of HCl, which is a strong acid. So it means that strong acid. So Cl minus is a weak base. It is not strong base. Now OH minus ion is the conjugate base of H2O. H2O, which is also a weak acid. Weak acid. So it is also a strong base only. So it is fairly strong. And in case of CH3O minus, so CH3O minus is, so it is the conjugate base of CH3O plus or CH3COH. Uh, no, I mean CH3OH, which is methanol, which is a very weak acid. It's a very weak acid. And CH3CO minus, which is the acetate, it is the conjugate base of CH3COH, which is also a weak acid. But out of these three, CH3OH is the weakest acid. CH3OH is the weakest acid. So it means its conjugate base also will be the strongest base. It is strongest base. So option C is the correct answer. Then here it is told for the reaction, the equilibrium constant cannot be disturbed by. So here the enthalpy, the change in enthalpy is negative. It is minus Q kilojoule. So it means that the reaction is exothermic. Since why it re- re- releases Q kilojoule amount of heat. So the reaction is exothermic. So now the equilibrium constant, as we know, equilibrium constant Kc, it is independent of Kc, it is independent of the concentrations of the products and of the reactants So therefore, if we change the concentrations of A or D, if A or D concentration is changed, then also then also the value of Kc will remain unchanged. Will remain unchanged. Will remain unchanged. And here, since it is exothermic, so if the temperature is increased, the value of Kc decreases, and when temperature decreases, the value of Kc increases. So by increasing temperature, there will be a forward shift. If we increase the temperature, then the reaction quotient, which is Qc, will be more than Kc. So then there will be a backward shift in the equilibrium. There will be a backward shift. So if we increase the temperature, then the equilibrium constant will change. And if we increase pressure also, if we increase pressure, then also the equilibrium constant Kc will remain unchanged. It will remain unchanged only since why? Since here delta Ng, which is equal to the number of moles of gaseous products minus the number of moles of gaseous reactants, that will be 2 minus 2, that is equal to 0. So since there is no change in the number of moles when the reaction happens, A plus B gives C plus D. So here the number of moles of the gaseous products is also 2, and the number of moles of gaseous reactants, that is also 2. So 2 minus 2, that is 0. So there is no change in the number of moles. So it means the reaction is the equilibrium constant of the reaction will be independent of the change in pressure. So Kc is independent of the pressure change. So it means the A, B, and C options are correct. A, B, and C, all three options are correct here. Since if we add A, some A also, and if we add D also, and if we increase pressure also, then also the equilibrium constant will remain unchanged. Then here it is told that Ka values for the acids H2SO3, HNO2, and CH3COH are these. Which of the above acids produce stronger conjugate base in aqueous solution? Stronger conjugate base in acidic solution. No, stronger conjugate base in aqueous solution. So the the conjugate base, the rule is that the conjugate base is stronger for a weaker acid, So it means the conjugate base of a weaker acid will be stronger. So now, as we know, the strength of the acid, if the Ka value is higher, then the strength of the acid will be higher. The strength of the acid will be also higher. So now here the value of Ka is highest. Value of Ka is highest in case of H2SO3, and if the value of Ka is the least, then the or if the value of Ka is less, then the strength of the acid is also less. So it means the value of Ka is the least in case of HCN. So it means that HCN is the weakest acid. HCN is the weakest acid out of all these four acids, which is the sulfurous acid, nitrous acid, acetic acid, and hydrocyanic acid. So the hydrocyanic acid HCN is the weakest acid. So it means that its conjugate base will be the strongest. It's, so it has got strongest. So it has got strongest conjugate base, which is Cn minus. So Cn minus is the strongest conjugate base. So option D is the correct answer. And here it is told 1 mole of Hi is heated in a closed container of capacity of 2 liters. 1 mole of Hi is heated in a closed container. 1 mole of Hi is heated in a closed container of capacity of 2 liters. Okay. So 1 mole of Hi, it will give half mole of Hi2 and half mole of H2 will be gases. Now 1 mole is heated at equilibrium, half a mole of Hi is dissociated. Half a mole of Hi is dissociated. So 1 minus 0.5. 0.5 mole has dissociated to form 1 by 4, that is 0.25 mole of I2 and 0.25 moles of H2. Then here the equilibrium constant. So and here the container capacity, that is the volume, that is equal to 2 liter. So therefore at equilibrium, the number of moles of Hi, or I can say the concentration of Hi, that will be equal to the number of moles of Hi, that is 0.5 divided by the volume, which is 2. So that is 0.25 molar or mole per liter. And similarly, the concentration of H2, that will be equal to 0.25 divided by 2, that is 0.125 molar. Similarly, the concentration of I2, that will be also 0.25 divided by 2 liter, that is 0.125 molar. Now, therefore, the equilibrium constant Kc, that will be equal to the concentration of H2 whole power half into the concentration of I2 whole power half divided by the concentration of Hi. So that will be equal to 0.125. It means it is, so this is 1 by 4, this is equal to 1 by 8. This is equal to 1 by 4. This is also equal to 1 by 8. So this is 1 by 8 into 1 by 8 whole power half divided by 1 by 4. So this will be equal to, so therefore now, therefore Kc that will be equal to 1 by 8 square root of 1 by 8 divided by 1 by 4. So this will be equal to 4 into root over, no, this is root over 1 by 64. It is just 64 root over 1 by 64. So that is 8. So 4 into 1 by 8, that is also equal to half. So the equilibrium constant is also half, which is equal to 0.5. So it means option, sorry, this is HI. Okay. So you have to use integral coefficients actually. So here 2 moles of HI will give 1 mole of I2 and 1 mole of H2. So it means that the equilibrium constant will be H2 concentration into I2 concentration divided by HI whole square. So this will be 1 by 8 into 1 by 8 divided by 1 by 4 whole square. So that will be equal to, so this part is wrong. So therefore Kc that will be equal to 1 by 64 into 16. 16 4s are 64. So it is 1 by 4, which is equal to 0.25. So option A is the correct answer. Then here it is told which among the following has highest pH. Now the 1 molar H2SO4, it means from H2SO4, in the first case from H2SO4, the concentration of H plus ion that will be equal to 2 molar. Therefore, the pH value that will be equal to minus log of concentration of H plus, which is minus log 2. That is equal to minus 0.3. And for B, it is from NaOH, the concentration of OH minus ion, that is equal to 10 power minus 1 molar. Therefore, POH that is equal to minus log of hydroxide concentration, that is 10 power minus 1, that is 1. So pH value that will be 14 minus POH, that is equal to 13. And in the option C, that is from HCl, the hydro the H plus ion concentration that is equal to 1 molar. Therefore, the pH value equal to minus log of H plus, which is minus log 1, that is equal to 0. And in option D, that is from NaOH, we will obtain hydroxide ion. So the concentration of hydroxide ion that is equal to 10 power 0, means 1 molar. So therefore here the POH that is equal to minus log of OH concentration, that is 1, that is equal to 0. So therefore pH will be equal to POH, which is 14 minus POH, that is equal to 14. So it means the highest value of pH is in 1 molar NaOH. So option D is the correct answer. Then here it is told at 500 Kelvin for a reversible reaction A2 plus B2, the gaseous form gives 2AB, and the Kc value is 2 into 10 power minus 5. In the presence of a catalyst, the equilibrium is attained 10 times faster. So the equilibrium constant in the presence of catalyst at the same temperature. So when catalyst is used, the value of the equilibrium constant will not change. Only the equilibrium will be attained in a shorter time. So it means the equilibrium constant in the presence of catalyst at the same temperature will remain unchanged. So the Kc value will remain unchanged. So the same value will come, which is 2 into 10 power minus 5 only. So option B is the correct answer. Then it is told a weak acid. There is a weak acid having pKa value that is 5.9, and a weak base is there, its pKb value is 5.8. They are mixed in equal proportions, then the pH of the resulting solution is, the pH of the resulting solution is, now here, okay, so pH value that is for in a solution of weak acid and a weak base, that is given as 7 plus half pKa minus pKb. So that will be equal to 7 plus half of pKa, which is 5.9 minus 5.8. So that will be equal to 7 plus half of 0.1. So that is 7 plus 0.05. So that is 7.05. So option B is the correct answer. Okay. Then here it is told the swelling in feet and ankles of a aged person due to sitting continuously for long hours during travel is reduced by soaking the feet in warm salt water. This is because of the process will be osmosis. Since why osmosis is the pro process in in which the solvent moves, the solvent moves from a region of of lower of lower concentration to a region of higher concentration, to a region of higher concentration through a semi permeable mem membrane, through a semi permeable membrane. So when uh, the feet and ankles are swelling, it means that here the concentration of the salt will be high, and here if we put it in warm salt water, so then the here the concentration of the salt is high and here the concentration of the salt is low, so the solvent, which is the water, that will move from the salt water towards the feet. So this process is called osmosis. So option D is the correct answer. Then it is told which of the following salts on being dissolved in water gives pH greater than 7 at 25 degrees Celsius. So pH greater than 7, it means that it should be a basic solution. Should be a basic solution. So NH4CN, it means that it is a salt of a weak base, which is NH4OH, and a weak acid, which is HCN. So it is a neutral salt. So here the solution will not be more than 7. So, and here for NH4Cl, it is a salt of a weak base, which is NH4OH, and a strong acid, which is HCl. So it is an acidic salt. Since it is an acidic salt, so here the pH value will be less than 7. And here for KNO3 also, it is a salt of a strong base, which is KOH, and a strong acid, which is HNO3. So it is also a neutral salt. So here pH will be exactly equal to 7. And for KCN, it is a basic salt. It is a basic salt, since why it is a salt of a strong base, KOH, and a weak acid, which is HCN. So it is a basic salt. So it's for KCN only, the pH value will be more than 7. So option 4 is the correct answer. Then here it is told for a reversible reaction, x plus 3y gives 2z, the change in enthalpy, that is minus 40 kilojoule, and the standard entropy. So let's consider it as the standard enthalpy only. So the standard entropy of x, that is 60 joule per Kelvin per mole, and the standard entropy for y is 40 joule per Kelvin per mole. and the standard entropy for Z, that is also equal to 50 joule per Kelvin per mole. Now, therefore, the change in the standard change in the entropy in this reaction, that will be equal to the sum of the entropies of the products minus the sum of the entropies of the reactants. So therefore here that will be equal to uh, sum of the entropies of products. So it will be 2 into entropy of Z minus entropy of X plus thrice 3 times the entropy of Y. So that will be equal to 2 into 6. So sorry, 2 into 50 minus 60 plus 3 into 40. That will be equal to 100 minus 3 4s are 12. So this is 180. So it is minus 80 kilojoule. Sorry, minus 80 joule per Kelvin per mole. So the change in enthalpy, that is minus 40,000 joule. So now we have to find the temperature at which the above reaction attains equilibrium. So therefore we know that when equilibrium is attained, then the the change in Gibbs free energy delta G naught, that should be equal to 0. And so now delta G naught, it means it is delta H naught minus T delta S naught. Now that is equal to 0. It means that delta H naught, that is equal to T delta S naught. Now it means the temperature at which the reaction attains equilibrium, we have to find out. So that T will be equal to delta H naught divided by delta S naught. So that will be equal to minus 40,000 joule divided by minus 80. And the answer will come in Kelvin. So that will be equal to 500 Kelvin. So option 2 is the correct answer. Then here it is told the pH of 10 power minus 8 molar HCl solution is. So now here, since the concentration of HCl is less than 10 power minus 6, so so we have to so we need to consider the H plus ion concentration from pure water also. We need to consider the H plus ion concentration which is water obtained from water, H2 also. So therefore, as you know, water, in water, uh, the concentration of H plus ion, that is equal to 10 power minus 7 only, 10 power minus 7 molar, since it is a neutral solution, So now, therefore, the net concentration of H plus ion, that will be 10 power minus 7 plus the H plus ions which is obtained from HCl, so it is 10 power minus 8. So therefore, this you can write, that will be equal to 1.1 into 10 power minus 7, you can write. So now, therefore, the pH value, that will be equal to minus log of H plus concentration. So that will be equal to minus log of 1.1 into 10 power minus 7. So this will be equal to 7 minus log of 1.1. So it is slightly less than 7. It's slightly less than 7. So it is the value of pH between is in between 6 and 7. So option 3 is the correct answer. Then here it is told the solubility product of a salt AB, that is equal to 1.1 into 10 power minus 8 molar square in a solution in which the concentration of A plus ion, that is 10 power minus 3 molar. The salt will precipitate when the concentration of B minus ions is kept. Okay. So now the rule is that if the ionic product of the sparingly soluble salt, which is AB here, so the ionic product KIP of the sparingly soluble salt, if that is more than the product, solubility product, which is KSP of the salt, then only the salt will precipitate. And only the salt will precipitate, else the salt will not precipitate. Now here, the ionic product of the salt, that will be equal to the concentration of A plus times the concentration of B minus. And the concentration of A plus is given 10 power minus 3. So therefore 10 power minus 3 into concentration of B minus ions, that should be more than KSP, that is 10 power minus 8. So it means concentration of B minus should be more than 10 power minus 5 molar. So if the concentration of B minus ions is more than 10 power minus 5 molar, then only the salt will precipitate. So option 3 is the correct answer. Here it is told that 4 moles of SO2 okay, 4 moles of SO2 and O2 gases are allowed to react to form SO3 in a closed vessel. At equilibrium, 25% of O2 is used up. At equilibrium, 4 moles, okay, 4 moles of SO2 and O2 gas. 4 moles each of SO2, so 4 mole SO2 and 4 mole O2 is used to react to form SO3 at equilibrium. So it is at T equal to 0. Here 0 moles of SO3 has been formed. And at equilibrium, 25% of O2 is used up. So it means that 1/4 means 4 minus 1 mole. So here also 4 minus 1 mole of SO3, SO2 gas will be used. Uh, so here also 1 mole of SO2 will be used up to form 1 mole of, so here actually SO3. So we have to first balance the reaction. So it will be 2SO2 plus O2, that gives 2SO3. So here 4 moles and here 4 moles is used. Here 1 mole has reacted. So here 2 moles of SO2 will react. And here 2 moles of SO3 will be formed. So therefore at equilibrium, the total number of moles of all the gases, the total number of moles, that will be the number of moles of SO2 at equilibrium plus the number of moles of O2 at equilibrium plus the number of moles of SO3 at equilibrium. So that will be 2 plus 3 plus 2, that is equal to 7 moles. So option 2 is the correct answer. A precipitate of AgCl is formed when equal volumes of the following are mixed. So then here it is told the precipitate of a precipitate of HCl is formed when equal volumes of which of the following are mixed. That has been asked. Okay, so from here, so AgNO3 and HCl, they are not sparingly soluble salt. They are completely soluble salt. But AgCl is a sparingly soluble salt. So the KSP for AgCl, that is equal to 10 power minus 10. So for precipitation, for precipitation, the rule is that if the ionic product, of the salt, that is KIP, that is more than the solubility product more than the solubility product, that is KSP, then only the salt will precipitate. Then only the salt will precipitate. Else it will not precipitate. So now here in the first case, the KIP, the ionic product, that will be equal to the concentration of Ag plus into the concentration of Cl minus. So that will be equal to the same as the concentration of AgNO3, is 10 power minus 4 into concentration of HCl, that is 10 power minus 7. So that is 10 power minus 11, which is obviously less than 10 power minus 10. So here there will be no precipitation. There will be no precipitate formed here, since here KIP is less than KSP. In the second case, KIP, the ionic product, that is equal to 10 power minus 5 into 10 power minus 6, that is 10 power minus 11, 10 power minus 11 again. And then, so here also, so which is also less than KSP. So here also no precipitate will be formed. And in the third case, in the third option, here the ionic product, that is KIP, that will be equal to 10 power minus 5 into 10 power minus 4. So that will be 10 power minus 9. Now that is obviously more than 10 power minus 10, which is the KSP. So here precipitation will happen. Here precipitation will occur here. And in the fourth case, in the fourth option, the ionic product, that is equal to the concentration of Ag plus, that is 10 power minus 6 into the concentration of HCl, that is equal to also 10 power minus 6. So that is 10 power minus 12, that is less than 10 power minus 10, which is less than KSP. So here precipitation will not occur. So it means that option 3 is the correct answer. So in case 3 only, in option 3 only, the uh, precipitate of AgCl will be formed. And okay. So hope all of you, okay, no. So in any questions, any doubts if you have, then please write that in the comments section. Okay, so here 20 ml of 0.5 normal HCl and 35 ml of 0.1 normal NaOH are mixed. The resulting solution will. So here the number of moles of H plus ion, the number of moles of H plus ion, that will be equal to 0.02 liter into 0.5 molar, that is 5 to the 10, so 0.01 moles. And the number of moles of hydroxide ion, that is equal to 0.035 into 0.1 molar, that is 0.0035 moles, 0.0035 moles. So it means that 0.0100 I can write. So here, therefore, the number of moles of H plus ion, that is more than the number of moles of hydroxide ion. So the resulting solution is acidic. So the resulting solution is acidic in nature. Resulting solution is acidic, since more H plus ion is there than the number of hydroxide ion. So the solution will turn methyl orange red. So the solution will turn methyl orange red, methyl orange red since it is acidic. And if if it would have been if it is a basic solution, then only it will turn phenolphthalein solution pink. And since it is acidic solution, so it will turn methyl orange red, and phenolphthalein will be colorless. Phenolphthalein will be colorless. And if the solution is basic, for basic solution, it will turn phenolphthalein pink. It will turn phenolphthalein pink. It turns phenolphthalein pink. Okay. So option 4 is the correct answer. And here it is told a buffer solution has equal volumes of 0.2 molar NH4OH, which is a weak base, and 0.02 molar NH4Cl, which is an acidic salt of the weak base. So the pH value is, and the pKb of the base, the pKb for NH4OH, that is equal to 5. So now, so it is acting as an acidic buffer. It is acting as an acidic buffer solution. So therefore, the pH value that will be equal to it will be equal to pKb plus acidic buffer. It is no, it is a basic buffer. Since why it is a weak base plus its salt, so it is a basic buffer. So here we have to find POH. So POH will be equal to pKb plus log of the concentration of the salt by the concentration of the weak base. So therefore here POH, and from here we can find out pH also. How? pH will be equal to 14 minus POH. So now POH, that will be equal to pKb, which is 5 plus log of the concentration of salt, which is 0.02, divided by the concentration of the weak base, which is 0.2. So that will be equal to 5 plus log of 2 by 20. So that is 10. So it is 5 minus log 10. Log 10 is 1. So 5 minus 1, that is equal to 4. So POH is equal to 4. So therefore pH will be equal to 14 minus 4. So that is equal to 10. So pH will be equal to 10. So option 1 is the correct answer. And here it is told the species among the following which can act as an acid and a base is. So HSO4 minus, it can give H plus ion. So it is acting, so it can give H plus ion. So it can act as a Bronsted acid, and it can accept, and it can also accept H plus ion, and accept H plus ion to form H2SO4. So it means HSO4 minus is also a Bronsted base. So it can, so HSO4 minus can act as an acid also and as a base also. So it means option 1 is the correct answer. And in case of option 2, SO4 2 minus, it can't act as an acid, since why it can't give H plus ion, and also it can't accept a lone pair of electrons, so it is not acting as a Lewis acid also. And H3O plus, it can give H plus, but it can't accept H plus, so it is not a Bronsted base. And Cl minus ion, it can't give H plus ion, so it is not a Bronsted acid, and it can't accept lone pair of electrons also, so it is not a Lewis acid also. So, okay, but it is a Bronsted base since it can accept H plus ion. So HSO4 minus only is the only one out of these four which can accept and give H plus. So option 1 is the correct answer. So it can act both as a Bronsted acid and a Bronsted base. Then for the reaction N2 plus O2 gives 2NO, the value of Kc at 800 degrees Celsius, that is equal to 0 0.1, when the equilibrium concentration of both the reactants is 0 0.5 mole. When the equilibrium concentration of both the reactants is 0 0.5 mole, then the value of Kp at the same temperature is. So, okay, so the value of Kp as we know, it is equal to Kc into RT power delta Ng, RT power delta Ng. Okay, so here Kc will be equal to the number of the m- the molar concentration of NO whole square divided by the concentration of N2 into concentration of O2. Now, the, the equilibrium concentration of both the reactants is 0 0.5 only. So this will be half, this will be also half. And NO concentration whole square, that is equal to 0 0.1. Therefore, NO concentration, that is equal to 0 0.1 divided by 4. Therefore, NO concentration, okay, okay, that can be found. But here delta Ng, that is equal to the number of moles of gaseous products by the minus the number of moles of gaseous reactants. So that will be 2 minus 2, that is equal to 0. So therefore here Kp will be equal to Kc only, which is equal to 0 0.1. So option 2 is the correct answer. And here it is told if in the reaction N2O4 gives okay, N2O4 gives 2NO2, X is that part of N2O4 which dissociates, then the number of molecules at equilibrium will be. So if initially 1 mole of N2O4 was used, then X moles has been dissociated, X moles of N2O4 has been dissociated, and 2X moles of NO2 has been formed at equilibrium. So therefore, the total number of moles at equilibrium, the total number of moles at equilibrium, that will be equal to 1 minus X plus 2X, so that is equal to 1 plus X. So option 3 is the correct answer. Then here it is told 15 moles of H2 and 5.2 moles of I2 are mixed and allowed to attain equilibrium. So 2 moles of HI will be formed from 1 mole of H2 and 2 moles of 1 mole of HI. 1 mole of I2 will react with 1 mole of H2 to form 2 moles of HI. And here it is told the equilibrium is attained at 500 degrees Celsius. Then at equilibrium, the concentration of HI is found to be 10 moles. Then the equilibrium constant for the formation, the equilibrium constant for the formation of HI will be how much? So it will be the equilibrium concentration of HI whole square divided by the equilibrium concentration of H2 into equilibrium concentration of I2. So here initially 15 moles of H2 was taken, and so 5 moles will react to form 10 moles of HI, and 5.2 moles of I2 was initially taken, and so 5 moles of I2 will react to form 10 moles of HI. So therefore at equilibrium, the concentration of H2, okay, and let's say the total volume is suppose V. The total volume is V, suppose V liters. So then at equilibrium, the concentration of H2, that will be equal to 10 moles divided by V liters. So that is 10 by V mole per liter. And the concentration of I2, that will be equal to 0 5.2 minus 5, that is 0.2 moles divided by V liter. So that is 0.2 by V mole per liter. And similarly, the molar concentration of HI, that will be equal to 10 moles divided by V liter. So that is also 10 by V mole per liter. So therefore, the value of Kc, that will the equilibrium constant for the formation of HI, that will be equal to molar concentration of HI whole square divided by molar concentration of H2 at equilibrium into molar concentration of I2 at equilibrium. So this is equal to 10 by V whole square divided by, so this is 10 by V whole square divided by 10 by V into 0.2 by V. 10 by V into 0.2 by V. So 10 by V, that will cancel. So this is 10 by V into V by 0.2. So this two will cancel out. So 10 by 2 by 10. So this is 10 into 10 by 2. So this is 2 5s are 10. So this is equal to 50. So the equilibrium constant is 50. So option 1 is the correct answer. Then here it is told that now, okay. Here it is told that 56 gram of nitrogen and 8 gram of hydrogen gas are heated in a closed vessel when at equilibrium. 56 gram of N2, so N2 plus 3H2 will give me NH3. So then it is told that at equilibrium, so 56 gram of nitrogen, it means that molar mass of nitrogen is 28 grams. So 2 moles was used initially at T equal to 0, and 8 gram of hydrogen. So it means that 4 moles, 4 to 8, so 4 moles was initially taken, and 0 moles of NH3 was initially formed. But at equilibrium, 34 gram of ammonia is formed. Now the molar mass of ammonia, that is 14 plus 3, that is 17 gram. So 2 moles of ammonia has formed. So it means that one okay, so that is 2 NH3. So here 1 mole of N2 has reacted. So 2 minus 1 moles is remaining at equilibrium, and here also 3 moles has reacted. So 3 moles of hydrogen, so 4 minus 3 moles is remaining. So therefore at equilibrium, the number of moles of nitrogen, that is equal to 1 mole, and the number of moles of hydrogen, that is equal to 1 mole, and the number of moles of ammonia, that is 2 moles. So therefore the answer will be 1, 1 and 2. So option 1 is the correct answer. Then here it is told, in the manufacture of ammonia by the Haber's process, which of the following condition is unfavorable? So here we know that Kp equals to Kc into RT power delta Ng. So here delta Ng, that is the number of moles of gaseous products minus the number of moles of gaseous reactant. So that is 2 minus 4, that is equal to minus 2. So since according to Lee Chatelier's principle, the rule is that the um, the equilibrium always shifts in that direction in which the pressure, in which the number of moles decreases, or in which the pressure decreases. So here so here N2 plus 3H2 gives 2NH3. So here the number of moles of the reactant is 4 and the number of moles of reactants is 2. So here the number of moles decreases. So it means the pressure also decreases in the forward direction. So it means high pressure is required. So high pressure is favorable. So increasing the pressure is favorable. And since it is an exothermic reaction, it releases 92.3 kilojoule of heat. So here it means that low temperature is favorable. Since why? If the temperature is decreased, then the Kc value will increase, means the equilibrium constant will increase, then the reaction quotient Qc will be less than Kc, then there will be a forward shift in the reaction. So forward shift, it means that more amount of ammonia will be formed. And here also reducing the temperature is more favorable, and removing ammonia as it is formed. So Kc will be equal to the concentration of NH3 whole square divided by concentration of N2 into concentration of H2 whole cube. So if the concentration of NH3 it is decreased, then it means that Qc will be again less than Kc, then again there will be a forward shift. So it means more amount of ammonia will be formed if we remove the ammonia as it is formed. So 1, 2, and 4, these are favorable conditions. These are favorable conditions, and increasing the temperature is an unfavorable condition, since if we increase the temperature, then the value of Kc will decrease and there will be a backward shift. There will be a backward shift. So option 3 is the correct answer. Then here it is told the chemical equilibrium of a reversible reaction is not influenced by. The chemical equilibrium of a reversible reaction is not influenced by concentration of the reactants, temperature, pressure, and catalyst. Okay. So the chemical equilibrium of a reversible reaction is not influenced by a catalyst. Since why? Uh, when the concentration of the reactants will change, if that changes, then it means the reaction quotient will not be same as Kc. So hence it means there will be either a forward shift or a backward shift in the equilibrium. And when temperature increases or decreases, then also it can influence the equilibrium if it is an exothermic or endothermic reaction. Then pressure also can influence it if delta Ng is not equal to 0. And catalyst will not influence the equilibrium, simply it will increase the rate of the reaction, or it will simply just increase the rate at which the equilibrium is attained. It means if catalyst is used, then the equilibrium is attained more faster. The equilibrium is attained more faster. So it means the equilibrium will not be influenced. So option 4 is the correct answer. Then it is told in a mixture of acetic acid CH3COH and sodium acetate, which is CH3COONA, the ratio of concentration of the salt to the acid is increased 10 times. It means the concentration of the salt to the concentration of the acid, that is increased to 10 times. Increased to 10 times. Then the pH of the solution, how it will change, that we have to find. So it is a mixture of a weak acid and a basic salt of a strong, a, a basic salt of the weak acid has been mixed. So it is acting as an acidic buffer. It is acting as an acidic buffer. So now for acidic buffer solution, we have pH value will be equal to pKa plus log of concentration of the salt by concentration of the acid. So here we have to use the value of pKa, which is the a- which is the Ka for the weak acid. So now since the concentration of the salt and the acid, it is increased to 10 times. So it means suppose the initial value of pH was pKa plus some log x. Let's say the initial ratio, let's say the initial ratio was x, and the final ratio is, suppose the final ratio of the salt and the acid is suppose 10x. Suppose 10x. So now therefore the initial value of pH was pKa plus log x, and then the new value of pH will be pKa plus log 10x. So that we can write it as pKa plus log x plus log 10. Now log 10 is 1. So it will be equal to 1 plus the 1 plus pKa plus log x. So it means the pH value will increase by 1 unit. So option 3 is the correct answer. Now here it is told the pKa value for the strongest acid is acid from the following is. So now when, so we know that if the acid dissociation constant, if the dissociation constant of the acid, which is Ka, if the Ka value increases, then it means the strength of the acid is higher. And it means that the strength of the acid is also higher. So now if Ka value is higher, if Ka value is higher, now pKa, as we know, pKa is equal to minus log of Ka. So if Ka is higher, then the pKa value will be lower. So it means the least value of pKa. So if we have least value of pKa, it means that it is the strongest acid. It means that it is the strongest acid. So it means the least value of pKa is in case of the third option, which is 1. So option 3 is the correct answer, since for pK equal to 1 will be the strongest acid. Since it's since if pKa is equal to 1, it means the Ka value will be 10 power minus 1. And if suppose pKa value is 3, it means that the Ka value is 10 power minus 3. So Ka value will be lesser if the pKa value is higher. So therefore the third option is the correct answer. It is the strongest acid. Then here it is told the, the compounds A and B are mixed in equimolar proportions to form the products. So A plus B gives C plus D. So they are mixed in equimolar proportion to form the products. So equal number of moles. Let's say here also uh, n moles of A was used and n moles of B was used, was taken at t equal to 0. And at equilibrium, one third of A and one third of B are consumed. The equilibrium constant of the reaction is. So at equilibrium, what happens? So at t equal to 0, no moles of C and D were formed. And at equilibrium, one third of A is consumed and one third of B is consumed. So n minus n by 3 is the equilibrium number of moles of A and B. And here also n by 3 moles of C and D will be formed. So now therefore the equilibrium constant Kc, that will be equal to the concentration of D into concentration of D divided by concentration of A into concentration of B. So that will be equal to, now let's say the total volume is V, suppose. So therefore the concentration of C will be n by 3V, concentration of D will be n by 3V, then concentration of N will be 2n by 3V, and concentration of B will be 2n by 3V. Since 3n minus n, that is equal to 2n. So n by V, those will cancel out. Then it will become 1 by 3 into 1 by 3 by 2 by 3 into 2 by 3. So that will be 1 by 9 into 9 by 4. So that is equal to 1 by 4. 1 by 4 means it is 0.25. So therefore, the Kc value is 1 is, so it means the equilibrium constant of the reaction is 0.25. So option 2 is the Correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCT exam on the chapter chemical and ionic e- equilibrium. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, in any other chapter of chemistry, if you have more difficulty, then please write the name of that chapter also. We shall solve more and more previous year KCT exams on that chapter, which shall be helpful for your exam. And also, please install our Sapience Education application, where we shall upload some more important previous year KCT exam on every chapter of chemistry. So thank you. So thank you everyone. Bye.